Hello, it's Valentine from Simplistic. In this video, we have a reaction. N2O4 gives us 2NO2. It's at equilibrium. The equilibrium constant is given to us. And there's some extra information out here. Don't worry about that. And that's the reason. The reason for this information is because this is an adapted question from a different problem. So what we need to be concerned about is that initially, we have only the reactant and the concentration is given to us, and there's no NO2. We need to find the equilibrium concentrations of N2O4 and NO2. So let's try to kind of put this down in the form of an ice table. So let's go ahead and write our reaction out first. N2O4 gives us 2NO2. And the ice table, you have your initial, your change, and your equilibrium. That's my ice, ICE. All right. And the initial concentration is this much for N2O4. So that's going to be 0.0250. And there is no NO2, which means that's going to be 0.00. So when equilibrium is reached, there's going to be a change. And so N2O4 is going to go down by, let's say, X. And N2O4 is going to go up by 2X. And the 2 is here because of the stoichiometry of the reaction. And then if you add this all up, that's going to be what we have at equilibrium. So that's the N2 quantity at equilibrium. And then this is the NO2 quantity at equilibrium. So now we have this. The next thing we have to do is we have to write the equilibrium expression, which is Kc is equal to NO2 raised to the power of 2 over N2O4. Okay, we plug these values in. We have 2x raised to the power of 2 over 0.0250 minus x. And this whole thing is equal to 0.36. That's what's given to us. So really, we have to solve this equation out here for x in order to find the equilibrium concentrations, because that's what the problem wants us to do. So once we find out x from this equation, we can plug x in out here. So 2x would be the equilibrium concentration for NO2, and 0.0250 minus x would be the equilibrium concentration for N2O4. So let's go ahead and solve this. This is essentially going to become a quadratic, but let's go ahead and simplify that. So I'm going to write that out here. That's going to be 4x squared over 0.0250 minus x is equal to 0.36. And then I'm going to multiply both sides by this quantity. Just by this quantity. So then when I do that, I get 4x squared is equal to 0.009 minus 0.36x. Now I'm going to take everything on the right and I'm going to push it to the left and make the right equal to 0. So that gives me 4x squared plus 0.36x minus 0.009 equals to 0. And now we have a quadratic equation. So let's compare that with a regular quadratic, which has the form ax squared plus bx plus c is equal to 0. And if you solve a regular quadratic of this form, then x would be equal to negative b plus minus square root of b squared minus 4ac, and the whole thing is over 2a. So you need to know this formula. This formula will not be given to you. You need to know this formula for solving a quadratic. And we're going to plug this formula into this to figure out how to solve it. So before we plug it in, we need to figure out what's the a, what's the b, and what's the c. So let's go ahead and write that down. So a is equal to 4, b is equal to 0.36, and c is equal to negative 0.009. So now we know what they are. So now let's go ahead and set it up. So x is equal to negative b, which is 0.36. So that's 0.36 plus minus square root of b squared. So that's 0.36 square minus 4AC. So 4 times C, which is negative. I keep forgetting the negative. Negative 0.009. And the whole thing is over 2A, which is 2 times 4, which is 8. Let's go ahead and write that as 2 times 4. All right. So once we have this, now let's go ahead and simplify what's under the square root sign. So we get, I'll leave everything else as is. So negative 0.36 plus minus square root of 0.36 square gives us 0.1296 minus this entire expression simplifies to 0.144. That ends up being negative 0.144, and then coupled with this negative sign, that makes it a positive 0.144. The whole thing is over 8. All right, so we go ahead and simplify that again. So therefore, this entire expression becomes plus minus 0.5236 over 8. Okay, and now at this point in time, we have two scenarios. We can have minus 0.36 plus 0.5236 over 8. Or we could have minus 0.36 minus 0.5236 over 8. The scenario on the right is actually going to be a negative. It's going to give us a negative answer, and x cannot be negative. Therefore, we're going to scratch this one out. We don't care about that. This kind of solution is called an extraneous solution. Okay, extraneous. So we don't care about the extraneous solution. We care about the real solution, which is actually this, which simplifies to 0.0204 molar. So that is what x is equal to. Okay, so if we have to find out what is 2x, the concentration of NO2, which is 2x, so all we have to do is concentration of NO2 is equal to 2 times 0.0204, which is equal to 0.041 molar. And then the concentration of N2O4 is equal to 0.0250 minus x, which is x is equal to, I forget what x was. X is equal to this. So that's going to be, so that is equal to 0.005. Because this is the final answer, I rounded these to the correct number of significant figures. So there you have it. That is the concentration of NO2, and that is the concentration of N2O4 at equilibrium. I hope that made sense. Thank you for watching.